Yeah. So last week we talked about tangent line. Do you understand it? So let me go to tangent line. Did I show you the decimal thing or no? Okay, so the tangent line basically, you guys can get a computer out. And if you ever go to open up decimals on the side, they give you like they give you already something already built in. It's called examples. And example, you can go in, they see lines, points to form, parabola. Do you see that on your decimals? And I want you to scroll down to calculus. And I want you to scroll not the derivative, but just the secant line here. It says secant line, it says calculus secant line on the side. Did I show you this on Friday? Okay. So basically, I want to find the slope at 0.5, right? On Friday, we mentioned this, except my drawing is very, very crappy compared to the actual things. So is the 0.5 here, which is the point on the left, with this point on the left. And at 2.5 is another point. It's going to create something called secant line. Now, the distance from here to there is going to be 2 units, right? It's 2 units. But what happened is the equation tangent line just basically shrink the secant line from h equal to 2 down to almost close to 0. So I'm going to show you, it looks like this. So it starts with secant line. You're going to evaluate that tangent. So you're going to see that the things moving is right now the slope is 0.359 and slowly decrease and use the limit approach. But we cannot approach 0. 0 is going to be undefined. That's why it says undefined. So, but what we can do is close to something that really close to it, like 0.00001. If I approach there, then I can get an estimate value of the slope if it's a secant. So it's roughly 1.17758. And that is the tangent line. Okay. Now, what's nice thing is this. What if we want to find slope at all moments? We can keep the h as 0.0001, and we just zoom out here, and we're gonna click the play button, and you will see that the tangent line is flowing throughout. And looks like the momentum, direction of the roller coaster, right? Do you see that? That's how you feel like, it's going away. And this is actually now what you can do on decimals. So which is pretty interesting. Some people says, I want to see what the tangent line look like. This is what the tangent line look like. Okay. And anybody have access to this. That's a nice thing about decimals. Decimals, anybody have access to this, and you can learn to see the things that usually normally don't see. Okay. So that was the tangent line. Now let's talk about calculus. We can talk about limits. But before we talk about limits, there was something called rule of 4. So what is rule of 4? Just in calculus, you want to look at these 4 things all the time. The first thing you want to look at is algebraically. The second thing you want to look at is graphically. The third things you want to look at is analytically. And the fourth thing that you look at is numerically. So numerically, so algebraically, I will say if I will give you percentage of breakdown, I would say probably 50% of times you can evaluate everything by using algebra. So algebraically is probably still a primary goal because that's what people feel most comfortable about. Now this estimation, this is pure estimation. So I say graphically probably 35%. A lot of time you're gonna deal with graphically and you have to learn how to read graph, read tables, and those are the things that you gotta be able to read. I would say another 10% is going to be analytical. Not a lot of people get to this level. But if you can think analytically, it's going to help you in the biggest round to understand the big pictures. To understand, it's not study the small things, to actually understand how the big things works. And analytically, it's like knowing when x is equal to this, what would it be? Estimation, a bigger slope or negative slope or whatever. Numerically, just plugging each individual value, that usually happens very, very small amount of time, and that doesn't really increase your test score. So I would say you want to focus on first three, algebraically, graphically, and analytically. Numerically, just understand how this graph works, or how this number works. So that's rule 4 in calculus. So always look at full perspective. Next time I'm going to ask you, in today's question, I'm going to ask you, what does a graph look like? Without plugging in decimals, you should be able to tell me what a graph look like. Now, I'm going to start with finding limits algebraically. Okay, algebraically, the thing is about limits, most of the time you're gonna plug in the value. Okay, sorry. Let me go to plug in the value. So most of the time you're gonna plug in the value. And that's your first step. Just plug in and see what happens. If you plug in value and you get certain situation, so first situation you're gonna get is you're gonna get a number. So you get, let's say you get a number. That's pretty much you're done. You don't have to do anything else, just plug in the value. So for example, when limits as x approach 2 at 2x plus 4, then just plug in the x as 2, so it'll be 2 times 2 plus 4, that's equal to 4 plus 4, that's equal to 8. And that's it. You don't have to do any further work. That's it. Now, other times like this, though, however, you're going to get a next case. If I get a number, you're done. If you get 0 over 0, that is the special cases, which is most primary. What you're going to get today's homework is all 0 over 0. But you still have to plug in to verify is 0 over 0 or not. Because something else over 0 is different situation. So you still have to do that first step by plugging the value. Now 0 over 0, there's a term. It's not undefined what people thought would be. Number over 0 is undefined, but 0 over 0 is not undefined. It's actually, this new name is called indeterminate. Indeterminate. Indeterminate, just not able to determine. Depends on the question. Some questions 1, some questions 2, some questions 3, some questions 3.5. We don't know. It's not able to determine. Okay, so it's not gonna be right away. So when you have a 0 over 0, basically I would tell students it's very simple. You're gonna do math. And I'm serious, just math. What kind of math are you gonna be facing? Well, most of the time is algebra. The first thing is do algebra. So algebra, do some type of algebra, it's just gonna be factor, and cancel. So if you factor something, cancel. How many kind of different factor you gotta be able to do? Difference of the squares, sum and difference of the cube. So we're gonna talk about a couple of situations. Second situation, if you see a radical, you're gonna do conjugate. And most of you guys don't know what conjugate is, but you're gonna do something called conjugate, which is rationalize. That's another term, rationalize. The third thing that you might see, you're gonna have one homework question about that, hoping people can do it. It's gonna be combined fractions. And that's only when you see a complex fractions. So complex fraction. What is a complex fraction? If we have fraction over fractions. So combined fraction when you see a complex fraction. Combine them fractions, simplify. Fourth, you might see absolute value. Then you're going to deal with piecewise function. For definition of absolute value. For one-side limits. Okay, so this one is going to be one-side limits. Yeah. Now you might get other cases we're not going to talk about until Thursday, which is going to be some type of number over 0. This is actually the easiest case. But number over 0, you're going to do one-side limits. One-side limits. But we're not going to talk about it right away. If it's one-side limits you have to deal with is they might get positive result with A, it's infinity. B is negative infinity. C, if you reach both sides, you might get does not exist. Okay, so hold on. This one is going to be using definition of absolute value. Okay, so this is a big picture. Now, one of the big picture I'm going to also mention is not mentioning now, as opposed to later. You're going to see something called L'Hopital rule, which is you're going to learn it at later in the year after you know how to take a derivative. Right now, it's not suggested to know L'Hopital rule because you don't know how to take a derivative. So you cannot do that. So that's why it's not on here. There's also infinite limits we're going to talk about. But overall, first few days, first week when we deal with limits, it's going to be all this. Yeah, it does not exist. D and E means does not exist. Okay, so let's talk about the first possible choice. I'm going to give you some simple cases. Today's homework, you're going to have some harder cases. But the simple case is going to be like this. As a limit, x approach to 2, x squared minus 4 over x minus 2. First of all, instead of going algebraically, which is algebraically is pretty simple. It can be done in like 10 seconds. But instead of thinking algebraically, do you know what this graph look like? Now that's a harder question. What does this graph look like? X squared minus 4 over x minus 2. Yes.
Wouldn't it like it's like this, it would go like
Okay, you said reciprocal graph.
reciprocal.
Okay, it's not a reciprocal graph, but that's a good try. That's good first try. Anybody can tell me what's the graph of x squared minus 4 over x minus 2 graph look like? Yes, Emil? It be linear, okay. Is there anything special about that line?
Could have a hole.
It could have a hole. Very good. Okay. So, did you look it up or you actually knew it?
Well, I knew that you would be dividing so you get x to the first power.
Okay, so good. So let's figure out x squared minus 4 is divided by x minus 2. So if you say divided by x, this is what the thing that Austin was talking about. Because when x is equal to 0, this thing become undefined. Then you have something called asymptote. Actually, in this case, there was two asymptotes here. There's one asymptote is linear. It's called slant asymptote. I believe y equal to x. There's the asymptote like right here. But don't worry about that. The asymptote is x equal to 0 in this case. Is that point never touch? Okay, but the problem is the question is not like that. It's minus 2. So it becomes no asymptote. It becomes a one straight line. This is no ordinary line. If you pay attention, there is some problem in these lines, and you have to pay close attention to it, right? So if you look at this graph, let me know, see if you see anything special. Like, do you see any y value? X or y value there is up and down. Okay, now I want you to pay attention, see if you can see anything special. Did you see anything? Let me go backwards. Do you see it? There's a undefined. Remember the other day we were talking about a black hole? This is a black hole we're talking about. It's a very, very small value of the undefined points. It's just, it cannot be too big. Otherwise, it'll be injustice, right? It's very, very small value. And that small fine value is going to be an open hole. And that open hole is very important. Okay. And let's talk about why do we need to use limits? Why can't I just plug in 2 here? I cannot plug in 2 because it's undefined. So therefore, I had to plug in limits. We know when we plug in 2, we got undefined. So what we're going to do is we're going to plug in 1 first. And we got value 3. We're going to plug in 1.5. We got 3.5. We're going to plug in 1.75. We got 3.75. We got 1.9. That's going to be 3.9. And then 1.99 is 3.99. Do you see that? And the more 9 I add in, the more accurate it gets to. This is why the limits. Limits assume that you can get to 4, but you're going to get very close to 4, but not on 4. So if I increase the 9 is on the other side is also increased. If I increase again, right? Eventually they go to 4 because the calculator cannot run up that fast. So they will get to 4. So that's going to be eventually 4. Also, limits approaching from both sides. So 2.01, 2.001, 2.00001. So that's how you get there. So you can get to 2. So there's an open circle there. So we're going to talk about that open circle. So let's show you where the line is located at. If you equal to, if I plug in the value, it's going to be 4 minus 4 over 2 minus 2. So that's 0 over 0. That means I have to do math. Guess what? The math I'm going to do is factor. Not only that, that's going to cancel. And that's why the line looks like this, x plus 2. You guys should already know how to graph x plus 2. That's just y-intercept at 2. and slope is at 1. Now, some people say, so what's the limits? Well, assume that you can get to 2. So it'll be 2 plus 2, because I just plug in. That's equal to 4. If you plug in original equation, it's going to be 0 over 0. In this case, you plug in, you get 4. That tells me two things. One is there is a hole at 2 comma 4. Why is 2 comma 4? Because I plug in 2 at this new equation, right? I plug in 2. And then negative 2 plus 2 is equal to 4. I got 4. So the hole is at 2 comma 4. This is also another name in calculus. So this calculus name does not call it a hole. They call it a removable discontinuity. Why do they call it removable? If you think about a, let's say if a bubble gum, and I will try to tell people like a long time ago there was a commercial, and I think now you don't see commercial anymore. You see ad on YouTube. But back then, if you watch TV, there's a lot of commercials. And they usually have like a Geico commercial. They're very stupid. They just like something like even cavemen can do it. Something like the slogan. Basically, it was like there's a guy who was, fixing a leak at a Hoover Dam. So he climbed up the Hoover Dam. He sees the leak, which is there's a hole, and the water starts flowing out of the hole. And he basically chewed a bubble gum and just chew it and put it in a hole and just fixed it. And that's the commercial. I remember that very clearly because they have a very dumb commercial, and I'm not very smart. I like remember dumb things, and those are the things I remember. But I thought that's actually a perfect way to describe removable discontinuity. You can fill in that hole and will be continuous. So they call it removable discontinuity as opposed to hole. So they just have a fancy name of that. Okay? Does everybody make sense on this particular case? You have to be able to factor and you have to be able to cancel. Factor, everything type of factor is going to be on your first test or your packets. So you might have something different. The second case, what if I flip this over? Does anybody know what this graph look like without graphing it? X minus 2 over x squared minus 4. What will be this graph look like? Nobody can tell me? I'm not gonna hold my breath on this one.
Reciprocal?
Yes, they are reciprocal. At where?
The asymptote 2.
Not at 2.
Negative 2.
Negative 2. Good. If you factor this, right? That's equal to limits as x approach 2. And that says it's going to be x minus 2 over x plus 2 and x minus 2. Now, if you see this, this should cancel out, right? But when you cancel out, don't forget one thing to put a 1 on the top. So let's cancel. That's equal to limit x approach 2 of 1 over x plus 2. Now, if I plug in 2, just 1 over 2 plus 2, that's equal to 1 over 4. So, pay attention. Even at this moment right here, there is a something called vertical asymptote. At x equal to negative 2. Why? Because if I plug in negative 2 here, negative 2 plus 2 is going to be 0. 1 over 0 is undefined. So how do I find vertical asymptote? Is denominator is equal to 0, lead to vertical asymptote. On your test in the future, I'm gonna ask you vertical asymptote. You're gonna have to tell me denominator equal to 0. That means x plus 2 is equal to 0. But that's not the original denominator. If you do original denominator, it's gonna be 2 value, right? It's after you cancel. After you cancel factor. So make sure it's after you cancel, not before, not prior. The prior, you're gonna get 2. And that's both are called discontinuity. One is called removable discontinuity. Is removable continuous still exists? Well, how do I find removable discontinuity? This is how you find removable. Removable and discontinuity and whole. You're gonna use the cancel factor equal to 0. Why? The cancel factor is x minus 2 equal to 0, x equal to 2. So therefore, at x equal to 2 is gonna be the things. Y is equal to 1/2, 1/4 after you reach the limits. So the 2 comma 1/4 is gonna be removable discontinuity or whole. Now the rest here, the x plus 2, I'm going to label in black here. This is going to be a vertical asymptote. It's after you cancel. Questions? I want to talk about this question. So limit x approach to 2. X cubed minus 8 over 2 minus x. Is there something that's factorable here? What is factorable? It's on your calculus packet. Amil? Numerator. Can you factor numerator for me?
Would be x minus 2 times x squared plus 2x plus
Plus what? Perfect. Over x minus 2. How did he cancel it? How did he get that? Is actually this formula. It's a to the cube plus b to the cube is equal to a plus b times a squared minus ab plus b squared. It's called sum of the cube. There's a difference of the cube. It's like this. Okay. Basically, you're just going to cube this number and cube this number. So it's going to be x and 2. So left with the x minus 2, same as before. Now this is a squared, so x times x equal to x squared. ab is going to be 2 times x. And this is going to be 2 times 2, so that's good 4. The x minus 2 cancel out? Yeah. Yeah, you're right. I changed your question, so I forgot. So this one's going to be negative x minus 2. I factor out a negative sign on the bottom. And this part will cancel out. And now here it's going to be negative 2 squared plus 2 times 2 plus 4. That's equal to negative 12. So the answer is a negative 12. And that's the things that you had to be able to do. If you don't know how to factor yet, use a box. Some of you guys can factor that, like Emil knows how to factor that very well. That's great, right? That's called factor by grouping. But if you don't know how a way to factor, please use a box. And we proved to Emil says box has some interesting perspective, can help you solve different type of problem, right? We present him a question of SAT, I think last Friday, and he looked at the problem he didn't know how to do, and I said use a box, and he did it in like 30 seconds. Otherwise, you stare at it for 10 minutes, you can solve the problem. So even used that way, you knew how to factor. There are certain questions, box is going to be better. If you don't know how to use a box, come talk to me after school, then you can use a box. In this case, it's not a box. Any question about this particular case? Okay. Next thing we're going to talk about is this. This case. But before I talk about this case, I'm going to talk about SAT. How many of you guys take a SAT over the weekend? Austin is the only one? You did? Okay. How'd you do?
It was easier this time.
They always get a lot easier. Okay, so well, the older SAT used to have these questions. We're going to talk about that. The question of algebra question was 2i minus 4 over 3i plus 2. And they say rationalize this. Have you seen this before? And they will say change to a plus bi form. And sometimes they even just find a b. They didn't ask you to find a. We're going to talk about that questions in particular. And how is this question related to this question? This question is very, very easy. How do you rationalize this? Do you guys remember how to rationalize? Yes.
Numerator and the denominator by 3i minus 2.
3i minus 2. Do you guys know what is this called? What is 3i minus 2 relation to 3i plus 2? What is that called? Start with a C.
Conjugate?
Conjugate. So this is the conjugate of the denominator 3i plus 2. Has nothing to do with Spanish conjugate. Like people said conjugate, and you think about Spanish as language. But in math here is basically find the opposite of 3i plus 2. Not exactly opposite. It's the thing that will make i's goes away. The reason why it make i's goes away is using something called difference of a square. On SAT, they love difference of a square. What is difference of a square? A squared minus b squared equal to a plus b times a minus b. There is no SAT. Even they got so easy, they still have to have a squared minus b squared. It's one of the things that they always have to have it there. So if you pay attention that there is a plus b here and a minus b here. So the result is going to be a squared minus b squared. So it'll be 3i squared minus 2 squared. That is the distributing part of it. On the top, you have to distribute it. That's going to give you 6i squared minus 4i minus 12i plus 8. 3i squared, that means both go in the square, so it'll be 9i squared. Instead of I squared, I'm going to write in red. I'm going to say, hey, I squared and I squared here. And minus 4 here. And this is I squared. So anytime you have I squared, that means you're going to change into what? -1, right? So that's going to be 6 minus 18i plus 8 over 9, -4, and that's going to be -1.
Isn't it 16?
Can add the right 16. Oops, that's a different marker. 16, this is 16. So on SAT, you got to worry about this. So it's going to be -6 minus 16i plus 8 over -13, I think. And that's equal to 2 minus 16i over -13. Now you can split 2 over -13 plus -16i over 13. And that's equal to 2 over -13 plus 16i over 13. So B is going to be equal to 16 over 13. A is equal to 2 over -13. So A plus BI form, this is one of the things that they test on SAT. They might just test the bottom. They might just test the top. It just multiply 2i minus 4 times 3i minus 2. Now this is one thing that you're gonna get. It's called conjugate. How is that question help me here? I have a radical. How is that question? Help me. You're gonna multiply this by what? You have to change the sign, right? And then that's equal to limits as x approaches 0. Do not distribute, just keep that there is. Because you distribute, it's actually make the matter worse. Now on the bottom, it's going to be a squared minus b squared. Now square root of x plus 1 becomes x plus 1 square root square minus 1. What is square root x plus 1 square? Just x plus 1. Simple. So it'll be x plus 1 minus 1. And the x times square root x plus 1 plus 1. I say don't distribute it because if distribute, you actually cannot see it. What happened is those two is going to cancel out. What else can cancel out? The x, right? The x cancel out. So be limit x approaches 0, square root x plus 1 plus 1. That's equal to square root 1 plus square root 1. Because I plug in 0 for that. That's end up equal to 2. It's a beautiful answer. You just had to figure out what is the right answer here. The homework is not a lot because today I cannot cover too much and limits not that hard. It's already posted online. You can start now. By the way, if you want to fix your grade in the future, you must have all homework. So if you don't have all homework, you want me to change it to a 70, then good luck. I won't change it until you have homework. Yes. Because I just plug in 0 for x. Just so it'll be square root 0 plus 1 plus 1. Square root 1 is 1. 1 plus 1 is 2.
Wait, so what do you mean by like homework? Do you mean like if you did it or if you like turned it in?
In the future, Emodo is gonna shut down. So eventually you cannot turn it in. I have to look at it. So I will skim to look at it. There are some people I'm gonna be more after, especially people who have bad grades. I pretty much just random check. If I see like the day I check and you don't have it, then I, depend on luck of draw, right? If I assign 10 homework and for that day I check you didn't have it, then that's gonna hurt your grade. So, but don't take a chance. Just do homework because homework is, even though it's 20% your grade, it's affecting the rest of the 80%. If you don't do homework, you're not gonna pass. Huh? Yeah. So, but the problem is it's gonna affecting your rest of the grades. If you don't do homework as the rest of your grade, it's not anything else.
Because I forgot to turn in one of like the homework, so I didn't know.
I'm not that worried because I know I look at the people's grade, I already know who does homework, who doesn't. If you do your homework, you end up to be much better grade. And if you really are very good, in the past, like I said, there was a good student and a good negotiator with me. Says I don't want to do homework. I said okay, then you score 100 on your test. I don't really care. The problem is you're not gonna score 100, right? But I have people that who can really score 100 without doing homework. But unfortunately, I don't try that luck. That luck is all of them that who did that is has a perfect score on SATs. Like perfect. We're talking about national merit scholarships, like 1600 SATs. They're not like low. Sheila does that. You don't do some homework sometimes.
Well, that's when it's not necessary. Did you grade our tests?
Yeah,
Well, we didn't grade our tests.
You need out of them?
Yeah, because it's been like a week.
You know, I have life. I got party to attend to. How would you know? Am I?
It's just easy to tell.
What's that supposed to be?
Wow, I have one viewer who's watching me online. I have one viewer. See, I don't know who that is. Shout out to that person. I don't know. It says one viewer. Maybe. Comment below if you're watching. My only viewer is Mr. Beast. He's gonna give me $100,000. You know, Mr. Beast give out like $100,000 for those people that stream with no viewers. I should get it pretty soon though. I have 3 viewers now.